Hello, I'm Wilman, and this is the first video in a series of videos for my IB mid-years project. Currently, I'm working on an organizational application for students. I've used a ton of different organizational apps in the past, and none of them have had everything I needed all in one place or did exactly what I wanted them to do. So I'm hoping my organizational applications will meet both my needs and other students' organizational needs all in one place. When I envisioned for this app, which I decided to call Flow, I was in the state of complete focus on a subject and having no self-conscious thoughts, which is the aim of my application. It would help students effortlessly plan and execute work, all the while never leaving the flow state. This is a hard deadline for this project, so I've broken the features I wanted Flow to have into three categories. First, the must-have features. I think these are central to any organizational tool, which are an adaptive tool list, calendar, and the planner. The difference I draw between a calendar and a planner would be the calendar would hold events and due dates and show a larger time period, say for example a month, whereas the planner would show at most a week and be filled in with tasks or events and how long those tasks would take and when to do them. I also have a note in this lucid chart about it, possibly suggesting times to do stuff to the user. Then there's the adaptive to-do list, which is the centerpiece of my whole project. I would hope that as the user does a task on their to-do list, they have an option to have a timer to run so in the future an average is reached for types of work and then suggested in an optimal order. For example, the computer would know that science homework takes a while, so if it needs to be done by tomorrow, it should be done early in the night so the time doesn't run out. Then I would hope that the algorithm could possibly suggest different approaches to cutting down the user's to-do list. Next is the want-to-haves. These are features not super important, but would really add a lot to the project if I found time to add them. These are in order of importance: a project planner, compatibility with other organizational applications, and a habit tracker. The project planner is something that I have a really hard time finding on other apps, but is super important. Usually projects make up a large portion of the student's grade and seem daunting and time-consuming. If I could create a way to easily and visually break down a big project into a bunch of smaller steps, I think this would add a lot of value to Flow. So Flow is all about ease of use, and I'm sure people using Flow have tried other organizational tools. I think it would really fit with the goal if with a couple of clicks the user could pull over all the tasks, due dates, and other habits from Google Calendars or other organizational tools and put it in Flow. Lastly, the habit tracker. I found it important to start building a study habit, especially when taking IB or college courses, so I hope that a visually appealing and easy habit tracker could help others build those habits. But I would want it to be more than just click a button for a number to go up. I would want some way to communicate to the user the best way to incorporate new habits into their lives. Finally, the least important features, or the nice-to-have features, ones that would be cool for Flow but wouldn't add as much value as if the previously mentioned features would, which would be the ability to customize Flow, like changing the color or values or sizes, a way to block apps while working, and other miscellaneous features and other organizational tools offer. So far, I've mentioned a lot of really big ideas, some definitely more attainable than others. It would be a mix of it's going to take a mix of technical knowledge, of coding, creativity, and a lot of patience to fulfill these ideas. The easiest prerequisite I can work my way towards is learning the technical coding skills necessary to create the functionality of my app. Previously, I've messed around with Godot, a great lightweight game engine. I've created several games, one of which is on the screen now, a turn-based strategy game. Because Godot uses GDScript, which is kind of like a Python offshoot, I've decided to work with Python on this project. Specifically, I'll be using Tinker, which is a built-in Python library used for graphical user interface development, or GUI for short. Actually getting into creating Flow, I first needed to research how I would make a GUI. Interestingly enough, I had no idea what a GUI was before starting this, so I just searched up what can Python do, and I already knew what language I wanted to use. From there, I looked at a list of things Python could do till I saw one that matched what I was looking for, mainly something not browser-based, something that would show up as a little icon on the bottom of your screen and pop up in a separate window when initialized. I then went to build out a flow chart which has all the functionality I wanted for Flow. I did this because I want to break it down into manageable steps. I looked at it as it's a lot easier to create a to-do list and a calendar list application separately than Frankenstein them together and try and tackle them both at once. Now that I knew exactly what I needed to teach myself, which was the basics of Tinker and how to create a to-do list, I simply searched how to code lists with Python Tinker, and how to use Tinker. I then checked the credibility of the resources I found looking at publishing date and the publisher. But the great thing about free online coding resources is it's super easy to check their legitimacy by plugging their code into an IDE like PyCharm or the command line. The web page I ended up using for the to-do list was called Python Tinker To-Do List Step by Step, mainly because it gave me a feel of how Python and Tinker syntax would feel without all the complex explanations of how stuff worked. I never ended up using the code for Flow, but nonetheless, I thought it provided a great introduction to Tinker. The best source I used was Python GUI Programming with Tinker, which is a very comprehensive guide into the inner workings of Tinker without being a flat-out documentation of the library. It had several interesting demonstrations and follow-along projects, as well as challenges to test for learning. It worked for learning the basics of Tinker widgets, from the placement to attributes, and finally handling the user's input. This gave me a better idea of the inner workings of Tinker and allowed me to start thinking about how my code would look for Flow. Next, I work on trying to understand some basic UI and UX, UI standing for user interface and UX standing for user experience, and determined that while it would be a good idea to have proper UI/UX for the final version of Flow, it would be more important just to have functionality and common sense, and that common sense and intuitiveness of Flow would be my guiding principles for UI/UX in the meantime. With all that said, I'm now ready to begin designing and actually coding Flow. First, I started with a rough outline of various different panels of Flow and decided a master bar on the left-hand side to switch between functionalities would be a good place to start. Then I created a more detailed design more focused on the particular space and what the to-do list panel would look like, in which each box is a 4D by 40 pixel, and marking the design up with arrows to indicate different functionality. After I had an easy visualizer to work towards, I started the task of actually bringing my idea to life with code. An important term that's going to be helpful with the technical aspect of this would be widget. Widgets are the basic building block of everything in Tinker. Buttons, text boxes, or any other element of GUI of a GUI is considered a widget. First, I created a large frame to act as a page for my to-do list. Originally, I wanted to work with the grid placement method, which relies on a series of columns and rows used to organize where stuff would be placed. This ended up not working out, and I defaulted to the place command method, which involved giving the exact pixel coordinates and was specifically mentioned as a flawed method, but so far I haven't noticed any real issues with it. I enjoy how precise the method is. I can easily change anything that looks slightly out of line. The first problem I ran into how I would handle the functionality of the to-do list, which is how to show, add, delete, and sort tasks. Originally, I wanted to have one list box that would store all the information I needed. However, I couldn't figure out how I would be able to sort the data by date and type, so I split it into 3 list boxes, and eventually I'll have all connected and function in unison as one large list box. After I figured out how to show the task, I needed a way for the user to input more tasks to be shown for the process. So the process for adding new tasks involved prompting the user for input, getting user input, making sure you have all the necessary information, and then adding the data to the list box. Since I was using a dictionary to hold all my information for the list box, I simply needed to check the user input to the dictionary associated with the list box, which seemed like an easy task, but because of how I handled collecting user input, I encountered several issues. For the prompt part of the process, I needed to initialize a new frame that would hold the input boxes for the user to interact with, and then would press a button to confirm their input. This meant I needed to have 2 functions, one that would handle create a new frame that would have the input boxes and buttons, and a second that would be called and take the user input and add it to the dictionary. The first way I tried to approach this was having global variables that I could access in any function. So after the user gave the input, the global variable would equal the input, but I didn't really understand how the global and local variables worked until after I found a better solution. For example, it didn't quite make sense how I could reference a function I created on line 100 with code on line 50. However, I could reference a variable like the dictionary holding the task on line 5 if I created it on line 60. My workaround this would be to create a function that could accept arguments that would be checked and then added to the dictionary before updating the list box. The resources I looked at only showed 2 ways to connect functionality to the button. Neither of methods could handle passing more than one argument, and I needed to pass 4. Eventually, I found a short web post explaining lambda functions, which allowed me to pass multiple functions and multiple arguments. Then, when the button was called, the function called when the confirmation button is clicked will take the currently inputted information and pass it on. If everything is filled out, it will turn the arguments into a dictionary before adding the dictionary to the dictionary holding all the tasks. Then each list box was cleared before being updated with the new task list in the task dictionary. I plan to use this method of clearing list boxes, then repopulating it with either new tasks or a new order of tasks. This would mean I can easily organize a task dictionary with a variety of methods available to dictionaries and strings and pass them to the cleared list boxes. In summary, what worked best for me when I ran into a syntax problem like global variables, I could easily find a situation on the plethora of sites on the internet, and whenever I ran into a semantics problem or a logic problem like how should my code be structured to handle adding tasks, I would take paper, draw out whatever needed to happen with boxes and arrows connecting them. I'd then use that as a guide to figure out how all these moving parts fitted together. Something that didn't work for me was some suggestions in the guides, like using the grid method instead of the place method. One thing I could do better is properly documenting my code so I can avoid spaghetti code and be able to easily refer back to my code when needed. Thank you for watching my video.